is it for notes, I think, for the year. It's called, it's 9.2 in your book. I mean, we had to skip all the way to 9.2. They just added this one, and it's called Hopital's. That's how you say that. Hopital's rule. This is kind of cool that this is the last section that we are doing, Hopital's rule. And basically, we are going full circle here, which is really cool. We are going back to finding the limit of a function. So we're reversing all the way back to the first section that we ever learned in calculus. So let's just review some things that we learned in calculus. The limit as x approaches 3 of x plus 2. How do you find the limit as x approaches 3 of x plus 2? There are different ways you can do this. Remember, in review, you can find the limit by numerically looking at a table. You can do it graphically, or you can do it algebraically. I'm not going to finish that. If you look at the table, if you put in y1 equals x plus 2, and if you look at your table, as x approaches 3, the intended y value would equal 5. If you look at the graph, you put your first dot at 2, and you go up 1 over 1, up 1 over 1, up 1 over 1, and you keep going like that. If you look at the 3, the intended y value is also 5. And algebraically is just substitution. If you put 3 in there, you get 5. So that's just review. You can either use your table to find the intended y value, you can use the graph to find the intended y value, or you can use algebra by using substitution and plug it in there and get your intended y value. Okay, now let's do a little bit different one. Let's do this one. The limit as x approaches 2. And on here, you're going to have x squared minus 4 all over x minus 2. Okay, so if you look at this problem, when you do it numerically, there's going to be there might not be an error, there could be an error. When you look at the graph, there's supposed to be a hole. And when you do it algebraically and you plug or substitute the 2 in there, you're going to get 0 in the denominator. So what you learned on your first day of what calculus was all about is you learned how to factor the top, which was x minus 2 and x plus 2 divided by x minus 2. And what happens is you got rid of the x minus 2's, which made it 0 in the denominator, and you came up with a new equation that you can now substitute the 2 in to get the intended y value, which ends up being 4. Okay, that's what you learned about limits. And what the heck, we got some time on our hands. Let's just look at a graph. It's been so long that we've looked at limits. Let's just look at this one right here. 1, 2, 3, 4. 1, 2, 3. Let's put an open circle here, a closed circle here. Let's put a closed circle here, open circle there. And let's just do some. What is the limit as x approaches 3 from the left? Some f of x function. What is the limit as x approaches 3 from the right? Some f of x equals, remember this is f of x. As you're approaching 3 from the left, here's 3 and you're approaching it from the left, the intended y value is 1. the limit as x approaching 3 from the right, I'm sorry, you guys, I got you guys mixed up. Start again, I'm sorry. When you're approaching it from the left, the answer is 3. When you're approaching it from the right, you're approaching it from the positive side of it, it's getting closer and closer to 1. Since these numbers are different, the limit as x approaches 3 for this f of x function does not exist. Okay, let's just do one more. Let's do the limit as x approaches 4 for this f of x. Here's 4 right here. Here's the dot at 4. Is the right limit and the left limit exactly going to be the same answer? Yes, they're both going to be 1. The limit doesn't exist. Even if this was an open circle, the limit exists. Even if this was an open circle, it's just the intended y value, the limit still exists. Okay, that was just review from the first time you've ever learned limits. Now, let's go into L'Hopital's rule. Here's L'Hopital's rule. Let's do this one. Number 1. The limit as x approaches 0 of the square root of 1 plus x minus 1 all over x. Okay, we've never done one like this. What happens when you put 0 into your x values? What's going to happen? You're going to have 0 in the denominator, and then what do? Maybe you could look at your graph to come up with your answer, but maybe you can't use your graphing calculator to do this problem. What does L'Hopital's rule say to do? All they want you to do is the limit as x approaches some a value of some f of x over some g of x. All they want you to do is take the derivative of the top and the derivative of the bottom. And that's all you have to do. It's called L'Hopital's rule. So the limit as x approaches 0, what's the derivative of x? I'm doing this one first. The derivative of x is 1. What's the derivative of the top? Well, I know that 1 plus x raised to the 1/2 power. I'm going to do that one. That's the same thing as 1/2. Leave the inside alone. Take the derivative, or subtract 1, and make sure you take the derivative of the inside, which is 1, which is the chain rule. The derivative of that ends up being 0. What does that make? That makes the limit as x approaches 0 of 1 over 2. The 2 goes in the denominator, and so does the 1 plus x. If I plug 0 now in for x, I'm going to get 1/2. L'Hopital's rule says that if you don't want to do it by substitution or graphing, and what's the really cool thing is, I want to do this problem to prove to you. You only knew the first day of calculus to factor it in order to get rid of that denominator. Look at L'Hopital's rule. L'Hopital's rule says you can do this a different way. All you do is take the derivative of the top. The derivative of the top is 2x. The derivative of the bottom is 1, and still use the limit as x approaches 2. You plug 2 into there, and aha, you get the same answer. You just didn't know L'Hopital's rule the first day of school when you learned about limits, or the first day of calculus. So L'Hopital's rule always works if you get 0 in the denominator. Not always, but 99% of the time. Okay, let's do a couple more. Let's do this one. The limit as x approaches 0 of 1 minus the cosine of x over x plus x squared. When you plug 0 into the denominator, you're going to get 0. So I'm going to apply L'Hopital's rule to this problem. take the derivative of the bottom, and I take the derivative of the top. The derivative of 1 goes away. The derivative of a negative cosine of x is a positive sine of x. So I just used L'Hopital's rule, and I found the derivative of the top over the derivative of the bottom. And I want to plug 0 in here, and plug 0 in here. I get 1 on the bottom, and on the top, the sine of 0 is 0, which ends up being the 0. Let's see here. I'm going to do the stronger version of L'Hopital's rule. This is the stronger version of L'Hopital's rule. The limit as x approaches 0 of the square root of 1 plus x minus 1 minus x over 2 divided by x squared. When I plug 0 in, it doesn't work. I'm going to apply L'Hopital's rule. I take the derivative of the bottom, which ends up being 2x, and I take the derivative of the top. This is going to end up being 1/2 1 plus x raised to the negative 1/2. This goes away, and the derivative of a negative x over 2 is a negative 1/2. Okay, when I plug 0 in, it ends up being 0. The stronger version of L'Hopital's rule is just to do it again. It's called the stronger version of L'Hopital's rule. Now I take the derivative of 2x, which is 2. This cancels out because it's a number. I'm going to get a negative 1/4, leave the inside alone, and make this, subtract 1 from this, that makes a negative 3/2, which ends up being the negative 1/4. The 2 goes down there also because it's down there. And this little guy comes down here too, and it becomes 1 plus x. It's the square root of the cubed of 1 plus x. Now what happens when I plug 0 in? I get a negative 1 on the top. When I plug 0 in here, it's the square root of 1 cubed, which is 1. 4 times 2 is 8. Final answer is a negative 1/8. So now you know how L'Hopital's rule works. And I'll look at the worksheet to see if you need to do any more types of problems, but I think you've got the idea how L'Hopital's rules work.